Alright, pathologists, so today we're going to talk about disease control, but we're going to start off with how they spread. Okay, first we've got direct transmission, which is when I, through physical contact, pass the disease on straight to you. So whether that is through shaking hands, or fluids, or air, so bodily fluids, like saliva, blood, semen, vaginal fluids, etc. Aerosols, and that's when you sneeze and little tiny bits of bacteria or virus are living in the little tiny balls of spit. And these are our contagious diseases. Alright, then there's indirect. Now remember, contagious, that should be an I. Contagious does not mean the same as infectious. Okay, these are ones like a contagious disease is what I can pass directly onto you. So then you've got indirect transmission. So these are ones which are passed on via a vector. Now remember, a vector is anything which carries the disease from one organism to another, but isn't infected itself. So it can be an insect, like malaria, an animal, like a dog that could give you rabies, like it did with the teacher who left our school. Then there's air which can cause diseases if the air is contaminated, or water. Water is one. Cholera is a massive problem worldwide. And here's an example. So here's one lady. She's on holidays in Vietnam. She's got herself some malaria, and we're down by the delta. There's lots of mosquitoes, and the mosquito comes along, bites her, flies along, bites me, and now I've got malaria, and then I'm dead. And that's sad. So, because again, I don't want to die. I want to be awesome forever. So, we'll start off with the natural control. We've already covered this, so that's basically your 3 lines of defense, as well as, a good lifestyle like diet, stress. These things can cause diseases, so you want to minimize them. Now, if we go on to the next one. As they say, prevention is better than the cure. So we could have vaccinations. Now we're going to write vax just for space on our boards, and this is a bit crowded, but that's because there's a lot to cover. So vaccines cause an immune response, like the 3rd line of defense, and they can be used for both bacteria and viruses, and they tend to be very cost effective because they're very cost effective, a cheap way to prevent diseases, or just stop them from spreading. Vaccines work, and they do so much. There are a lot of people out there who are going to tell you that vaccines don't work, and they're wrong, and they're not lying to you because they probably believe it, but they're wrong. But vaccines work by injecting either a dead virus or part of the pathogen, so it's what we call an attenuated vaccine, or just by injecting the antibodies made in a different organism. We'll get to that in a sec. Side effects are rare. They're very, very rare, and they never, ever, 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 ever include autism. 2 types of immunity. There's so 2 types of vaccines, and one gives you active immunity, and this is where your body starts to make its own antibodies to fight off future diseases, and this happens by injecting a live but disabled, attenuated version of the pathogen, and this one can cause mild symptoms, but it's not a long-term sickness. Passive immunity, so they inject pre-made antibodies that then signal for attack. They react fast. This is the sort of thing we would use for rabies. If you get rabies, you get the vaccine after you're infected. So that's where this would work. Or in an emergency when a disease is, like, you're having an epidemic in a certain area. They're short-lived. They're fast, but they're short-lived. And you'll need a booster if the situation continues, and it's useful in emergency. neither last forever. If you want to be immune for a long time to a disease you have active immunity from, you'll still need a booster shot. So a booster is just the next step. If any of you have ever had, I think it's hepatitis B, you basically have 3 injections over the course of a year, and that ends up building a very strong, long-lasting immunity, but not forever. The most common treatment, particularly for only for bacterial stuff, it does not work for viruses, and we call ones for fungus antifungals. So antibiotics are what we use for bacteria. They kill off bacteria one of 2 ways. They either somehow destroy the cell, they target the cell and destroy them, or they interrupt the chemical or metabolic function. So the metabolism is just all the chemical reactions that happen. So there are 2 main types that we're going to talk about. There are the broad spectrum ones. These are the less desirable. Now broad spectrum, they'll just kill off all bacteria. They come in, or a large range of bacteria they come into contact with. And then you have the narrow range, or narrow spectrum, which they pretty much just kill off a target bacteria. Then we have resistance, and this guy's French resistance, a little World War II joke for you, because it was, a hilarious time, apparently. So, resistance. Antibiotic resistance is one of the scariest and more dangerous aspects of modern living. So bacteria evolved to be resistant to antibiotics, and yeah, they change and mutations happen because there's lots and lots and lots of bacteria in any population, and some are just attacked less less susceptible to certain antibiotics. Anyway, now there's 2 general ways this can be caused, and that's by overuse, and this is the current problem we're having in the livestock industry, where livestock is just given antibiotics in their feed, and it's controlled quite well in Australia, but overseas not so much. Or improper use. Now this is when you don't follow the instructions, or you don't take the antibiotics for long enough. So basically, if the infection is not severe and won't kill you, it's probably best to let your body recover naturally, because it will. Your body's immune system will eventually win, or you'll die. One of the 2. And this is what's leading to the current problem with tuberculosis. Alright, so that's it, my little pathologist, and yeah, we'll see you later on.